Alright guys, let me know if the link works to access the stream, and if it works just go to Discord and yeah, let me know there so we can start. Alright then. Well, welcome to one of the Exploit Pack premium trainings. This training is out of schedule. If you want to look at the formal schedule for 2020, choose Open Exploit Pack and go to Help Trainings, and then you will find the trainings planned for this year. This one is, as I said, is out of schedule. Basically, what we're gonna do with this training is gonna take a few sessions. I guess it's gonna take around 4 and 5 sessions. This is gonna be the first one, introduction. I also recommend you guys to go to the YouTube channel and look at the From Zero to Hero. That also will give you a short introduction of reverse engineering. On this one, of course, on this training, we're gonna cover a lot more than we have on that video. But so basically, on this one, of course, it's live. And if you have any questions regarding what we're doing, just go into Discord and pop up your question there. As I said before starting, you will need a virtual machine. You can use VMware or VirtualBox, and then from there, look at the CrackMe, put it there, and install IDA and Ghidra. That's some of the tools that we're gonna use. Those are the more important ones for this training. Besides that, some good sources for this type of challenge for ramping up your skills on reverse engineering are Hack the Box, of course, and CrackMe.1. Those two sites, on those two sites you will find challenges on reverse engineering that you can use to develop your skills even further. So we're gonna start with this. So if you want to follow along what I'm doing, please go ahead. No, it's not mandatory to have Ghidra, but I just want you guys to understand the type of tools that we can use on our arsenals of tools for reverse engineering. And Ghidra is it's a good one. It's a good one to have. It has a good decompiler, and there is even now a debugger for it that you can use. Besides that, you can interconnect IDA and Ghidra together as well. So let's go ahead and start with it. So as I said, this is gonna be a short introduction. I don't want to go too advanced on it. For instance, we have this binary. This is Exploit Pack CrackMe binary, and basically on this binary, this binary, as the name mentioned, is packed using UPX. But on this session, we're not gonna unpack it manually. We're gonna use a tool for it. I can show you two different type of tools that we can use to automatically unpack it. But on the next session, that I guess is gonna be in 15 days, we're gonna unpack an UPX manually, so I can show you how to dump the memory, the sections, and follow along UPX, and just get it done manually, so you understand how you can do it, and not only let the tool do it for you. But alright, so as I mentioned, I have IDA Pro. and also I have a few other programs here. I have the P editor. This is a portable editor, and then those are all portable, and also the PID. That as the name suggests, they are only for portable executables. And we also have Scylla. That's a tool we will use not now, but that's a tool that will help us construct a proper EAT, that's a import address table from a binary, take it from the original binary and put it in the dump one. But that we're gonna look into that in the next session. And then besides that, we have also Ghidra, binary ninja that we're gonna use, and solve crypto with force, and of course as well P Explorer. So okay, so starting this training, we will have this exploit pack UPX file. So let's see, let's check the binary in three different type of tools. So let's go ahead first with the binary ninja. So open binary ninja, so you can see the difference, how it looks in different tools, right? So we say open, and then we need to select the binary itself. Where is it? There it is. Okay, so binary ninja is gonna give you a graphical view only in assembly. Of course, it doesn't have any decompiler as far as I know. A feature map, a mini graph, you can see here on the right side, and then the symbols on the left side of the screen. And there are some windows you can change, some tools you can use if you want to do different type of analysis. It only does linear sweep. That's the most basic type of analysis that a tool can do. So basically GDB, Radare, binary ninja, they all do the most basic one, that is a linear sweep. Alright, well, from there you can choose follow along, and then you can select any of these graph, and then on the graph, of course, you can also change the color, highlight a block, add comments into it, jump into address. Also you can see this in a exa editor mode. You can look for tags if you have any. Yeah, and as you can see, binary ninja is a quite basic tool if you compare it with Ghidra or IDA. So let's go ahead and close it. Just want to show you a quick overview of it. Then we can do the same with Ghidra. So to run Ghidra, you will need Java as well, install on your machine, on this case it's a virtual machine. All right, so once open, well, it's already loading the code browser. I will say no. There, don't save. Okay, so the first, so the first thing you need to do, I already created a project, but the first thing you need to do is to create a project on Ghidra. You want to select if you want to share it or not share project, and then let's say training. You need to specify a name on it, and then for this particular project, we're gonna drop binary, this one. There you go. Okay, so it's gonna load the file into that project, and then well, it will just give you a quick overview of what you have loaded, and then yeah, you can just press enter, accept it before reading it, of course. From there you will have your binary there. IDA supports, Ghidra supports not only Windows, for Linux, and other different type of platforms as well. If you want to check which platform are support, you can go into the contents for Ghidra, sorry again, and look at there at the documentation. And documentation for Ghidra is quite good. Alright, so we have it here in Ghidra, and then you will have a tool chest. You can install more tools. Here, the one that is used for the compilation is the code browser, and inside those tools you can also have plugins on it. And if you want to find more plugins or tools that you can have into your Ghidra framework, then I suggest you choose to browse GitHub, and there are tons of those type of tools and plugins developed for Ghidra, because it's an open source project. So if you double click on it, it will open the default tool that is the code browser. And the code browser, as soon as it starts, it will ask you to analyze this binary that you just loaded. So you click on yes, and then you can select all the different type of analyzers that it has. For instance, do you want to check if for strings, and how do you want to check for strings in this one? So the minimum length, you can change it if you want. Force mode reload, string and alignment, the type of alignment. Of course, the model file, that's more for Ghidra thing, and all the other stuff. So if you can deselect all, or choose select all of them, and then choose click analyze. So it might take a few seconds. You can see it on the right bottom on the screen, the status. Well, we already finished it, but then here you can see here the program tree. So basically the segments that we have a header, 2 UPX segments, and a source segment here. So if you click on any of those, it will take you into it, into each the starting of that section. You can also look at the imports. These binaries calling, in this case, is calling all these libraries. So the APIs for Microsoft WinCRT and Kernel32, MS BCP, because it's a Visual Studio type of file. BC runtime, because it's a C file, and then the exports, there is only the entry point, while the functions, label, classes, and also the namespaces. Alright, I already added here the defining strings for this. It's kind of stuck. Alright, so I already added the defining strings Windows, but if you don't have it, then you can choose go into Windows, and then select the window that you want to look at. For instance, if we want to add the Python interpreter, well, now it's resetting Python, but then, when this is finished, then I hope it's finished. I never seen this doing that. Okay, took a while. Okay, so once this is finished, what you can have, so you don't have it as a window on top of your program, what you can do is to just grab it from the tab bar, and then you can drop it wherever you want it. I just move it here, and you can, so on that, like that, you can choose move your windows. In this case, I have my Python interpreter here. Alright, and as you can see, it's Python 2.7. I guess they will change into Python 3 at some point. And then from here we can see all our strings that we have on this binary. But as I mentioned, this binary is actually packed with UPX, so you cannot see, because it's compressed and you cannot see it. The only thing you can see is the UPX procedure that's gonna be used to decompress. So basically UPS will decompress one segment into the other one. So, but the one segment will gonna be used, part of that segment is gonna be used to run code that is gonna decompress that code and drop it into the segment that is gonna jump into, and then pass execution into it. For the import function that you can see here, this is quite useful. So for instance, if we go here and then we say exit process, you can see, well, you can go to show references or go to external location, but if you go to references, you can see where is it called for exit process from kernel32.dll, and this is something you can use to develop quite easily and follow DLL injections on different types of binaries. And and Ghidra as a static code analyzer tool is it's quite good. And as you can see here, you will have your assembly code that also it also supports graphical view. So it's not only it's not only text that you can see, so you can see it in a graphical way as well, as I show you on Binary Ninja. And here you can see how is it working with a function graph, function call trees, functional graph, and also this as well. If you want to have it choose like Ghidra, then you can choose move it here, and it might take a few seconds, but it will pop up there. So we need to put it here. There you go. And you can scroll. And the good thing about this is, like, when I click here, when I click exit process, it will show me in the assembly code where is it making that call here. See, and also so it will interconnect what is happening on this assembly. This is the pseudo the compilation code in C-like type of code, and if I go to the assembly, it will also try to it. So if I click on this guy, then it will choose connected to the pseudo code. Same for the graphical view. So it's quite good. It's quite user friendly, and as I mentioned before, it has a really nice documentation. So okay, let's close Ghidra. Before moving into Ghidra, I'm gonna show you Ghidra again, but with this binary unpacked. I'm not gonna unpack it manually. This is gonna be for a different session, but I can show you it here in Ghidra, and then open it in Ghidra again, unpacked, so you can see how it works. So alright, so this is Ghidra Pro, so this is not open source. So again, you have your windows, then you can see your strings, procmac segmentation, XView structure, nums, imports and exports. If you want to reanalyze it, then you can choose click here. It will analyze it by default. So right click here and reanalyze, as I mentioned. And then from here, something that I'm missing here, a window that I'm missing is the segment window. So go here, open. Oh, I was already there. I didn't notice. So UPX is 0 and UPX1. So click on UPX1, and then if you press space, if you are into a section that you can do it, then you can move into the graphical view. But you can also call it from there, a more graphical thing. So as I mentioned here, the UPX1 is a compressed code, and then from here, let's choose run it. So I choose set up a breakpoint here with pressing F2, and then I will select local Windows debugger. Do you want to run it? Yes, and then just hit my breakpoint. So if I realize it here right now, you can see that because I stopped the execution and realize the code, I can see a bit more of it. And then if I run the binary and realize, you can see that now my code is actually working. So what I can do now, if I have, because right now I choose run it, and then what's happened is that in memory during runtime, UPX choose run the procedure and decompress the section and jump into it, and then from there, if I want it, I can choose take a memory snapshot, and then take a memory snapshot from the loader segments. That's gonna be these two guys. And then from there, basically what I can do is to start manually unpacking this binary, but we're not gonna do that today, so I don't want to confuse you guys. So what you can do is to choose use again UPX. I should have it here somewhere, or you can use pExplorer from Heaven Tools. Choose open the file, going to this guy, just using the trial version, so save file again, and then unpacked. So now it automatically unpacked it for me. Heaven Tools also has a disassembler. You can also see the sections. Now let's say, so it's, but this type of disassembler will remind you more to Oli DBG, right, or WinDBG than IDA and Ghidra. These things are more well, basic. Alright, so let's close it. We already have it unpacked, so we have it unpacked here. But before going there, what I'm gonna show you guys is how the actual code looks like it. So for that, let's check the questions if you guys have any question. Oh, sorry. The password is exploit pack. Alright, so let's go back. Alright, so if we open exploit pack, so let's look at the source code. This cracked me. I have this particular crack me. I'm gonna show you the source code, but this particular crack me, I made it even easier. I removed all the memory protections for me, so you guys will find it more easy to solve. And also, by the way, today we have a much major issue with NTP. So basically, exploit pack has been using a NTP server from NIST.gov. So basically, it's an American NTP server that didn't work quite well. It was giving us a lot of timeouts, and some users were not able to register the product because exploit pack was timing out and hanging because it was trying to gather the time from the internet, and it was just failing. So what I did is just made a quick minor version and changed the NTP server to time.google.com, and that just works just fine and should be more reliable. So please go ahead and upgrade your exploit pack to 13.06. So if you have any problems, just go ahead and upgrade it, or you can just download a new version from the website. Alright, so go back to our exercise. This particular challenge is this one, EP challenge. This is the source code, so copy it. So what I'm gonna do is open Visual Studio, create a new project, and then Windows desktop application. Okay, let's connect like that. So I can show you the source code, and you can compare the source code with the decompiled source code, so you can see how it looks like. So we paste the source code here, and on our binary we don't have this type of protections like is debugger present, checking if it is inside a virtual machine, if in this case for PPC, VMware, so it's not checking for that. Or if a hardware breakpoint exists, then it will choose a drop or a trap flag. So that's not going to happen on this particular crack me, so I remove all of that, and also here is commented, as you can see. Also remove this this is a, so you can see exploit pack just trying to output a debug string, so basically it's calling this function. There's also a protection, basically it's a dumb protection, but it works for preventing you to decompile the code, actually to make the assembly code to translate it into pseudocode, because most of the decompilers, for instance the one for IDA Pro is called X-Rays, and that one has a default amount that is 64 kilobytes per function, and because we are creating a function that is way bigger, that's what's going to happen is that's going to just fail the analysis, and it's not going to be able to show you that. And then as you can see on this case, what it's doing is constructing the string using different type of string sets, and then it's gonna construct the flag. And then again, what you are looking at, some serial keys to take you out of your way. And then from there it's gonna construct the strings that they are not concatenated, so string 1, string 2, 3, 4, 5, they are all in different places, as you saw when I show you the flag. They are in different places, so this one goes here and there and there and like that, so it will construct it so you cannot actually follow in a linear way. And then and if you succeed, then of course you will you will get a message box saying well done, you have tried harder, then it's done. So basically this is the crack me running, and then you need to input here your flag and then click on crack me, and if it works then you get the flag, otherwise it doesn't work. I guess you get nothing then. Alright, so let's close it. And then let's look at the unpacked one inside Ghidra. Unpacked one. Okay. So Ghidra detector that is unpacked. Well, that's the program name. The last modified days, window, Indianness is little x86. That's the addresses, symbols, basically it's an overview, and the compiler is Visual Studio unknown, and then okay, we click OK. Now we can close exploit pack already, and then we need to open it with the code browser, so double click on it to open it by default with the code browser. So let's analyze it using all the analyzers available. Okay, what is doing that thing? Then what we're gonna also do is to put it in IDA. So go ahead and put it in IDA. IDA already detected all the proper segments. .text is where all our actual code is. Then we have eData, AirData, and data that basically on AirData, well, if you go to streams, you can actually see what is it. I was about to explain it, what AirData is, but AirData basically is where your variables are. So as you can see, congrats, you have completed this challenge. So if you want to follow this variable, then if you double click on it, you can see, okay, it was a reference to a string, and then if you press X inside the string or click here, you can click here to jump into the reference, or you can choose press X on the reference and show you. If it has more than one, it will show you here, but at this moment it has only one reference. So press OK, and I will take you to the reference of the string in the source code. And if you are not familiar with the assembly code, then you can choose go to Options, General, and also add the comments. Let's go again, so we don't have to move the mouse too much, and then like that. And then, as you can see, Ida added some comments into each line of assembly. So for instance, GA, it means jump if above, so if above CF equals 0 and set F, those are flags, are equals 0, then it's gonna jump. JB is a jump if below, so the flag CF needs to be equal 1, and jump if not 0. So this is a negation for she set. So jump if not 0. So basically, if the flag set F if equals 0. Well, and then you have some explanation like logical compare two operands, so that you can, of course you can see that by just reading the opcodes. It's always helpful to have a quick cheat sheet next to it, right? All right. So let's look at how it looks at the source code here, because when we jump into this string, we already jump into one of the main functions, right? So basically it's just big main. If we go to the Windows main, you can see that the Windows main, sorry, I forgot to explain that here on the left side we have all the functions named Windows. So you can see here all the function names, and you can also change the name of these functions. And you can see some of those were not detected. That's why some of those, they already have some names, yeah, but some of those were not detected, and that's why they are called sub. That means subroutine. For instance, this one, Ida new, that is choose calling free, and then is J free, and then is J free, because Ida detect that it's a jump to free, right? So if we go here and then we follow, then we can see there is a jump to free. That's why it's called J free. But in this case, it's a sub and then a number, and this number is the offset on the program, because Ida couldn't detect by signatures which function was this one, right? So you can see, you can double click on each function and then go into those. But so double click, and then you can choose jump into those. And if you want to change the name, so let's say okay, we say this one might be interesting for us, and we want to make a comment, then we can choose add a comment here, we can add a comment here and change the name to that subroutine. So click on the name of it, yeah, and then press N, and we can send a string too long, and that's going to be the name for this subroutine. And as you can see, it's also changed here, right? So let's go back to the reference for this one, and we check. And here also we can move to the graph window. Yeah, well, this particular binary is it's not really nice to move to the graphical view like this, but it's easier to choose go like that. All right. So from here, let's say, okay, this is a congrats. So this is the window, the function that we want to reach. So we can choose click on here on color and paint it on green, because that's where we want it to go. and then well, I guess this yeah, it's on the same one. So and also this one, but there should be an exit function, right? Like I was calling exit. So if you want to look at what is calling, you just go into import. It seems that at some point it's gonna call is debugger present. Okay, so if we go to imports, terminate process, we don't want to go there. So well, you can just start following there and see how is it being called, and then from where, and then going back, and then follow those jumps. But yeah, let's go back. Let's go back there. Well, that's the name of the function. So if you're gonna go back, you can press ESC. I'm on the Ghidra view, so let's go to this guy. And also, if you for instance, let's say you want to say I want to add. I'm not gonna show you how to do it now, but just want you guys to know that if I want to patch during runtime, not patch this program, there are two different ways of patching it. You can choose add a breakpoint here, press F2, and then click on edit breakpoint, and then you can set different type of breakpoints. For instance, well, enable. So if you want it enable or not, that's something useful to do. Type of breakpoint, you can have it as a hardware, module, relative, symbolic, on the source code, so because you can also put breakpoints on the source code in IDA. You want to, what's the action that is going to happen? Do you want to enable tracing, disable tracing, break or not break? So you can have it enabled but not break. Then you can set up a condition. For instance, you can say, okay, on this case, jump if not 0. So if you want it to jump, then we can set rec value and then set it to 1. And then we have a conditional breakpoint that every time it's gonna be reached, it's gonna break, but it's gonna break. So it's gonna stop the execution there, and it's gonna change this value to 1. Something that we want to do, we can do if you want to patch it with a breakpoint, is to not break, but every time it will pass through this, it will hit this breakpoint, not break, it will not stop the execution, but it's gonna change the flag to 1. Right? That's something. Well, I already explained. I say I will not, but I'm already explaining it anyway. So if we go to here, if you click on the dots, then you can choose the language, a scripting language that you want. I prefer to use IDC, that is the IDA scripting language. That's what it stands for. But you can also use Python if you want, because IDA supports Python. They have their own implementation of Python that is called IDA Python. Okay. Okay. So well. And then you can write your code here. And if you want to write snap snippets, so for instance, let's say I want to dump the test section, then I can choose go. That's what I had it there. So let's shift F2, execute a script, and then we can import a script, or we can choose use it as a snippet directly there. Well, then you can also select the scripting language. It also supports, as I say, IDA Python, and let's say I want to drop this segment. So I need to set from where. So it's gonna be from there to the end. That's basically the same, but 4000. So then if we run it, then you can see here on the output window, memory dump script, well, sorry, save as dump mem.bin from to. Right, so we close this guy, and then here we will see that we have our memory dump from that section that is actually the test section that actually contains the code. All right, so well, let's close this, and finally let's press F5. Let's remove this breakpoint. Pressing F2 on it, it will remove it. Sorry, something I didn't show you guys is, well, you need to select a debugger. IDA supports local window debugger, but it also supports remote GDB, remote Windows, and remote Linux as well. Okay, so on this particular binary, it doesn't show me Linux because it's not a Linux binary, so it doesn't. It's smart enough to not show you the the option to debug this on a Linux box. And if you want to do that, then you need to go into open file location and then go to debugger servers, and then you need to take this server. So you take Linux server 64 bits into your Linux box, basically a different VMware, and then run it there, and then choose run it. Let's say you select that one, and then you click there, and then you need to set up here the host name and the parameters and the port that is running that server on. But on this case, it's a P file, so we're gonna run it locally. So here you have your servers that you need to move into your target. And then and also you don't need to move your binary. You can have it here and then choose run it, and then IDA is gonna take care of copying that file into that target that you are running, the server that IDA is connecting to. All right, so let's press F5. Oh, sorry guys, again I forget the breakpoint list. So we have set one breakpoint, and as you can see, it's set ABS because it's on assembly, but you can also have a different type of breakpoint, and as I mentioned, there is the source code breakpoint. So now we press F5, and if you want to save this view, you can click on save desktop and save a view. Well, right now I'm saving it as a default, but you can have different type of Windows types, because IDA has two different views. Well, you can have more, but the most basic ones are the Decompiler view and the Debugger view. Right now we are on the Decompiler view because we are not running it. So if we set up a breakpoint and we run it, then we're gonna hit the Decompiler. So, well, we have a breakpoint there. It's a random breakpoint. It's not really necessary, but still we can use it. And let's say we set a breakpoint here on the source code, and you can see that IDA say, okay, I set up a breakpoint on this subroutine, and this is the offset, so plus 715. So that's the offset on this subroutine where IDA, and this is particular location where IDA set up the breakpoint on the assembly, and the source breakpoint is on this location, but now it has a two dots and a number because it's the line of the source code, right? So that's the location, dots 398, and here you have it. And if you want to set a different breakpoint, you can also press here, like if you were debugging inside a IDE, right? Okay. So we have two different breakpoints. It was gonna hit both. Well, actually, this one it's not gonna hit it. Oh, it does because I removed the condition. Let's say not hit that one, so it's not gonna hit that one, but it's gonna hit the source code one. All right. So as you can see, the code looks totally different, right, from what you were expecting to see, right? Because this is pseudocode. It's IDA only can read this code. So if I press space, I go back now again to the assembly. And if we press space, I go to the graphical view. And of course, you can move this around, right? And set up new lines and stuff. Okay. And this is the pseudocode for that function, because you can have pseudocodes for different functions, of course. And if you want to make it look like Ghidra, then you can do that as well. So you put it like this, and then boom, there you have it. But something doesn't have by default is that you can click here, but it will not link these two, right? But you can do that with a plugin, but still it doesn't do it by default, as far as I know. Okay, so looks sort of like Ghidra now. Okay, so this is the source code. Let's go up to a place that we can reference to there, and then here let's go to that place too. I guess this on the top. Okay, let's choose press F5, decompile it, and then close this guy, and then put it again here on the on the right side of the screen. Oh, doesn't let me. There you go. Just like that, and there you go. So we are here. Well done. You have tried harder. Well, we can also move this guy a little bit there, so we have more space on the screen, and also here like that. And here you can also have your Python interpreter if you want it. It's quite useful to have it. Okay, so this is how it looks. Let's with a breakpoint, and let's open it on Ghidra so you see the difference. Okay, so let's look for the screen, for the same string. Well done, you have tried harder. So when you click on this guy, Ghidra will automatically take you there. So we need to again follow the reference. So you can, what did it open? Oh, the reference window. So this just like IDA. So click on the reference, and it already took me there. Okay. Oops. So it's pushing the string. Have tried harder, but now it's working on the decompilation of it. Let's see how it's the difference between these two. It's taking some time. Oh, there you go. Okay, so now it's doing it. So basically, if I click here, then it will take me to here. So it detected it's a message box as well, IDA as well. So message box, parent, well done, you have tried harder. So it looks quite similar. The only different, well, you have to decide which one you like it most, but they are quite similar. To be honest, the IDA one is way better. It has more detection of signatures, and also for C++ type of code, they made a lot of improvement there. So you will have in Ghidra, you will have a lot of functions that they are not references, and you need to start changing the name and following the references in order to understand that it's just a basic printf. But on IDA it works way better. Anyway, so we have it here. Yeah, you can see it looks quite similar. They are both really good. And well, if you want to look at the disassembler, so if you click on web place, this is quite nice to have actually. So it show you where is it, and then you can scroll into it, To be honest, this is way better than IDA. This particular thing of well, I think they will add it in IDA, because it makes no sense for them not to have it. I mean, that you can choose, click here and say, hey, take me there, and it already takes you there, right? That's really useful. And again, you can also say, okay, well done, have tried harder, and then you can also choose a color and say, okay, I want it in green because this is the one I want to reach, right? And by default, it's choose a decompiler, so you cannot run this code, but you can install a plugin and then make it Ghidra to work as a debugger as well. All right. So I guess that was quite clear, and I assume you guys already found it. Did you guys found the key that it's gonna ask for, the flag? Let's go back to Discord to see if anyone found it already. You guys found it or not yet? It's right there on the screen, so you can see it. Let me take a sip of my drink. Okay. Well, this is a string, guys. So this is what is showing. So this is push, the push of the reference, and then this is a string. And as you can see, both detected it pretty well. So go there, and then you can see we have the reference. Again, here you can take it from here, say copy, and then go into the push for this reference. So basically, this is a string that is gonna ask for. But as you see, if I say, hey, push it, well, just hit my breakpoint. Let's should continue. Well done, you have to try harder. But what does that string is? Because that's not your flag, that's the string that is checking for. But if you want to, if you are in a CDF challenge, and you get the string, but you cannot submit it. So then you can use solve crypto with force, pass your string, and then it will decode it. Yeah, and it was using encoded using 555. The flag is exploit pack. And if you don't know this solve crypto with force, just get it from GitHub as well. It's really useful for CTFing. All right, guys. I hope you have enjoyed this training. And I guess I will see you guys again in a few weeks. The next training, well, of course, it's gonna be on reverse engineering again. It's gonna be the session 2. On the session 2, we're gonna start doing more real crack meets. This was just an introduction for you guys to know the tools. I recommend you guys to look at the video that is titled From Zero to Hero. It's also on the YouTube channel. And if you go there, you will find this also introduction to crack me, but it will take you to some real examples. And based on that knowledge, on the next session, we're gonna start doing maybe some crack meets from Hack the Box or from crackmeets.1. I will walk you through the process. At the end of this training, we're gonna start applying all this knowledge that we gathered to reverse engineering crack meets into real programs. Because basically we want to use our reverse engineering knowledge in order to understand a program, how it works, find vulnerabilities on it, and then try to exploit them. right? So in order to develop an exploit, it's quite important that you understand how to do proper reverse engineering into a program, because otherwise you cannot exploit something you don't understand how it works. Alright guys, thanks for tuning in, and I will see you guys again in a few weeks. Drop me any comment, or you have any questions, just feel free to contact me. Bye.